Hi, my name is Tanish, and this is my recommendation report presentation. Today, an ever-growing number of companies rely on cloud computing for their applications. But with this massive shift to the cloud, one problem has become impossible to ignore: skyrocketing cloud costs. Organizations spend millions every year running virtual servers, and a huge percentage of that money is wasted. So through this recommendation report, I wanted to explore a simple question, complicated answer. Should more companies adopt the new phenomenon of serverless computing? And what does that decision actually mean for cost, performance, sustainability, and security? Here's the path we'll follow for this presentation. We'll first set the stage with a look at what cloud computing actually is. Then we'll compare the technical performance of traditional server-based systems versus serverless architectures. Next, we'll explore how serverless abstracts away operational overhead, one of its most attractive features. And finally, we'll look at what sustainability and environmental impact, which has quickly become a key priority in modern cloud strategy. Cloud adoption has exploded over the last decade, and so have cloud costs. Traditional cloud computing requires companies to run virtual machines 24/7. Even when nothing is happening, those servers keep running. Companies keep paying. A study showed that 31% of IT leaders estimate that half of their cloud spending is wasted on idle resources. Serverless computing has emerged as a response to this problem. Instead of paying for servers that run constantly, companies only pay for the exact compute time their functions use. No servers to manage, no idle costs, but automatic scaling built in. It's an appealing idea, but is it always the right one? One of the biggest strengths of serverless is its ability to scale automatically. When traffic spikes, maybe during a product launch, serverless functions can instantly scale from 0 users to thousands per second. But there is a trade-off. Serverless systems suffer from something called cold start latency. If a function hasn't been used in a while, the platform has to initialize it, load code, allocate resources, or even start a container before it can respond. Studies show that these cold starts can take as long as the function's actual execution time. For some applications, like real-time analytics, financial tradings, that deal can break the entire performance of the application. So while serverless scales beautifully, that scalability doesn't always guarantee predictable performance. One of the most compelling reasons companies adopt serverless has nothing to do with performance at all, but rather operational overhead. With traditional cloud systems, company teams constantly manage operating systems, scaling policies, security patches, and capacity planning. It's a full-time job, often several full-time jobs. In serverless, all of that disappears. Cloud provider handles provisioning, maintenance, and scaling behind the scenes. Developers get to focus on writing application logic instead of babysitting infrastructure. This simplification shortens development cycles, reduces configuration errors, and allows teams to move much faster in development stages. But abstraction comes with a cost: reduced visibility. Debugging serverless applications can be harder because developers don't control the environment, and misconfigurations, especially involving third-party components, can introduce new security vulnerabilities. As companies think more seriously about sustainability, serverless offers real environmental advantages. Traditional servers remain powered even when idle, wasting energy and increasing carbon emissions. Serverless eliminates this waste by allocating resources only when functions are actively running. Studies show that serverless architectures can reduce energy consumption by as much as 70% compared to virtual machines. Major cloud providers have even reported tenfold reductions in their electronic footprint after shifting to serverless for internal workloads. So beyond cost savings and simplicity, serverless aligns strongly with modern sustainability goals. So, should companies adopt serverless computing? Here's the answer. Serverless is an excellent choice for applications with bursty, unpredictable, or event-driven workloads. These systems benefit the most from usage-based pricing, automatic scaling, and reduced operational costs. But serverless is not ideal for continuous, long-running workloads or applications with strict real-time performance requirements. The best approach for both startups and large companies is often a hybrid one. Use serverless where it shines, use traditional architecture where it remains more predictable, cost efficient. Serverless isn't the future for all cloud computing, but it is the future for the right kinds of applications. And knowing the difference is what allows companies to spend smarter, scale faster, and build more sustainable systems.